Hello, my name is Robert Harrison and I am a research scientist for the Department of Primary Industries and Regional Development in Western Australia and based at Murdoch University's Legume and Rhizodium Sciences in Perth. Topic background, a bit of background. In Australia we have had to domesticate new legumes as all of our productive legumes and rhizobia, so their microsymbiont that fixes atmospheric nitrogen, are both foreign to our soils. So nitrogen is one of the most limiting factors for plant growth. In Australia, we have some of the oldest soils in the world, thus really minimal soil nitrogen. Since the Green Revolution, nitrogen has been supplied by an energy-intense process called the Haber-Bosch process. Therefore, legume cultivation seems an obvious answer. But it's nothing new, as Theophrastus et al. Figured it out in early 400 BC. However, there has always been a focus on subsequent grain yields in this research with legumes in rotation, but not proteins as much and not really forage legumes. So it was quite handy to do this research because the group that I work in has domesticated new legumes and rhizobia that are better adapted to the drought conditions of southern Australia. Our research published in Agronomy for Sustainable Development focused primarily on sort of two issues. Wheat gluten is one of the planet's most important proteins, but cereal protein levels are falling rapidly. And secondly, the financial and environmental cost of using synthetic nitrogen to boost these protein levels needed for world population increases has been increasing substantially, especially after the Black Sea crisis. So we then set up a heap of crop rotational trials with different forage legume and non-legume crops rotated in subsequent seasons with wheat across different sites in Western Australia. But what we found was not only do the forage legumes increase the yields of subsequent wheat crops, they also boost the proteins due to the nitrogen fixed by the forage legumes being released at the right time for the wheat plant for when it needed it. Also, after a meta-analysis of all the sites that we studied and obviously combined all of them, we saw that continuous cereal rotations never achieved that sweet spot of high yield and high protein scenario, whilst legume cereal rotations never achieved a low protein, low yield scenario. Then we placed our sustainability ESG hat on and did some emissions modelling which identified that forage legumes in rotations reduced on-farm emissions by over 200 kilograms per hectare of CO2. So in a little bit of context, 50% of on-farm emissions come from the usage of nitrogen fertiliser. So that's a significant reduction. So not only will well-managed forage legumes in rotation both with cereals boost both on-farm profits and production, it will do this at a lower impact to the environment. Ultimately, biologically fixed nitrogen-fed grain proteins may appeal to consumer sentiment as the global focus on these GHG emissions does switch from big industry to agricultural production methodologies. So if you'd like more information on the topic or some bedtime reading, if you have trouble sleeping, please refer to the recent article published in Agronomy for Sustainable Development titled Increasing Wheat Proteins Sustainably by Rotation with Forage Legumes. So go forth and spread the good word of the forage legume.